So let's start with the definitions. Now, what is binary search? So basically it is a divide and conquer algorithm that repeatedly divides a sorted array or search array in half to find the target value or the optimal solution. Okay, so basically the time complexity is log n. So main thing is this time complexity. Okay, usually for searching an element from the array, let's say we have 1 2 3 4 5 6, right? What is the time complexity here? If we search for an element, let's say 5, we will do what? We will traverse the whole array using for loop, and we will find if our element is 5, that means this is the required element, right? It will take O n time complexity, right? The for loop will take O n time complexity, but here binary search can be useful because this array is sorted, right? This is sorted. We can apply the binary search. Now, how binary searches work? See, the main thing is it will divide the basically the array into the smaller parts. Let's say 1 2 3 4 sorry why eraser is not working now. Okay, 5 6, right? So this is the array, we need to find 5. How binary search will work? First we will check for the middle element, right? This is the middle element, right? Now we will check if the target is smaller or the larger than this mid element, right? It's larger, then our searching part will be this thing only, right? We will not check the element in this part, correct? So our searching part got reduced. So this is the benefit of binary search. Okay, so where we can apply this? So it can be applicable in two major contexts. That is the when we are given a sorted array and we need to find a particular element or the condition, right? Or the second thing is when the search space is numeric or monotonically increasing or decreasing, right? In that case also we will apply the binary search. Let's say we need to find the minimum or the maximum possible value, first or the last position that satisfy the condition, optimal value based, right, on some constraints. So these are some scenarios where we can apply the binary search. Okay, now how to identify binary search patterns? We will look for these signs or clue if the array is sorted and we need to find the element. In that case we can apply the binary search, right? In any case, if the left part is smaller than the right part or the element, here we can apply the binary search. Or we were asked to find the first or the last occurrence. First bad version, this is the question name. Okay, so the question where we were asked to find the minimum days, maximum capacity, smallest or the largest x with some condition. Okay, so these are some example of the question. Okay, after that, when we are allowed to search within a range, let's say between 1 to n, and we need to guess the number, we need to find the number. Okay, so how to apply? I hope everyone got this logic. Like we are given one array 1 2 3 4 5 6, we need to find a number or the target, let's say 5. If it's present, then return the index, right? Now how we will apply the binary search? See, the main logic is first we will find the mid element, right? There will be left, this is the left, the smallest number, that is 1. Okay, index is 0, and the right, the index is what, 6, right? So we will find the middle element using these. So it will be left plus right minus divided by 2, it will be 3, right? So this is the middle element, right? Now we will check the condition. What is the condition? If the target is greater than mid, right, then we will update the window. What will be the window then? First we were searching from here to here. Now we will search only this part, right? Only this part, because this target is greater than mid. That means it will come in the right side only, right? So we will update the left. This will be the new left, correct? Now this is the window, this is right. Again we will calculate the mid. In this case, what is the mid? Left is what? 4. Now the mid will be 5, right? That means this element, this is the mid. Again it will check if, then we will update the left as mid +1. Otherwise else, in the else condition, we will update the right. That will be equal to mid -1. See, in this case it's smaller, right? Target is smaller than the mid element. In this case we will update the window. That means we need to search on the left side, this side, right? So only one element is there, so we will be having one condition. If target equal to mid, we will return the index. Return mid. Mid is the index. Okay, so this is basically the binary search, the basic binary search. So this is clear, right? We will be having 3 things. First is mid, okay, first is left and the right. Okay, this is the smallest, this is the smallest, this is the greatest, and using these we will be calculating the mid index, and we will be comparing with the mid and the target, right, and updating our window accordingly. So this is basic binary search. Okay, so that's what I have written. We will calculate the mid and we will be having conditions, these conditions. Okay, left will be the minimum possible and right will be the maximum possible. Then these are the conditions. After that, the benefits. What are the benefits? Benefits will be like it is fast, log n time complexity, right? Because we are not traversing the whole array, we are in each iteration it's getting half, right? Let's say 1 2 3 4 5 6 and 7, right? This is the mid element, and with each iteration we are checking these conditions, right, and updating the window. With each condition it's basically our number of possibilities getting half, right? So the iterations are getting half at each iteration. So after first it will be n by 2, after second it will be half of this, right, n by 4, right? This is the window. After that, this is the only window, right? For each iteration we are getting half of the previous, we can say. Understood this part? Why it's log n? It's getting half at each iteration, so it is log 2n. So it's fast. Another thing is it's a smart brute force approach. Try all values smartly in the small time, works on custom condition checks, saves memory. We are not using extra space. Okay, we are working in place in most of the cases. In place means same data which we are given, right? Common problems: search in the sorted array, find first or the last position, the minimum and the maximum condition value, search on the custom function, lower and upper bound, right? Okay, so the first question will be the simple one. Binary search, we are given the array and we are given the target. We need to return the index if it's exists, right? So it's a simple one only. I already explained this. Let's solve it. So this is the array given, right? -1, 0, 3, 5, 9, 12, right? We will check if this is sorted or not. It's sorted, right? So we can apply binary search. We can apply binary search if it's sorted. This is the first condition. Okay, you need to check this. This is important. Okay, it's sorted. Now we will get what? Mid element, right? The left will be the smallest, right will be the largest. Left is 0. We will write the index, okay, and right will be what? 0, 1, 2, 3, 4, 5. 5. Okay, we will get the mid element, that is 2. This one, correct? Now we will check the condition. If target is equal to nums of mid, if this is the condition, then we can say return mid. This is the required answer, okay, but it's not equal, right? So we will check the next condition. Else if, now we will check if 9 is coming in the right side or the left side. We will update the window accordingly, right? So else if target is smaller than nums of mid, that means if it's smaller, that means this is the required window, right? We will update the right because left is the window, so we need to update the right as this point, okay? Mid -1, right? Otherwise, if it is in the right side, then we will update the left variable as mid +1. So this is the window, okay? And same will be happening with the next iterations, okay? With this array, we will get the left and we will get the right. We will calculate again. We will calculate the mid element. Again, we will check if target is coming on the left side or on the left side. So we will be having while loop, right? Within while loop, we will be checking these conditions. Else, we will update the left equal to mid +1. Got it, everyone? Let's code it. So let's have the length. Or no need. Let's have the left variable, that is 0. Let's have the right variable, that is nums.length, right? Dot length -1, correct? This is the last index, okay? Now we will be having one while loop, correct? Till when it will run? Till low is less than or equal to high, correct? Now we will be calculating the mid, that is equal to what? Right, anything left plus right divided by 2, right? We will get the mid element. After that we need to check the conditions, right? If target is equal to nums of mid, that means this is the required answer. We will return mid. Otherwise, else if condition we need to write, okay? Else if, what is the second condition? If it is not the target, then we need to check which is the window, which is the next window, right? We will check if target is less than nums of mid, that means this is the left side, right? Target will come on the left side. We will update what? Right, correct? As mid -1. Got it? After that, in the else condition, we will update the left pointer as mid +1. Basically, we are updating the windows. Got it? I think extra. Okay, at the end we can return -1 if it's not there, right? Let's run this. If low is, I'm using right left. So basically we usually use two variables, that is left or right, or low or high. Okay, this is the low value, this is the highest value, right? Let's submit this. Okay, it's submitted. So let's move to the second question then. Now you need to search in a 2D matrix. How will you do this? Like we were in the last question, we were having a 1D array and we are applying the left and the right as the lowest and the highest value, right? And we are getting the mid element. But in this 2D matrix, how will you do? Let's write it. So we were having this array, 2D array, right? It's like 1 3 5 1 3 5 7. You are saying to apply binary search on each array row, right? But yes, this will work, but can we optimize this? You will, in this you will be having the conditions, right? First we will check the left and the right, then we will move to the next array, then we can apply the binary search, right? But can you optimize it? See, one thing we can do is we can compare the first and the last number of the each row. If it's like the target is between the range, then we can apply the binary search, right? But again, we can optimize this more. Yes, we can. How? See, can we write this 2D array into the 1D array? Let's say 1 3 5 7, then 10 11 16 20 23 30 34 60, right? So let's say this is the 1D array, let's say. Okay, so we will be having the first index and the last index, right? If this is a 1D array, we will be having one left index, one right index, correct? So left index will be 0, obviously. What is the right index? What is the index of this? It's what? 0 1 2 3 0 1 2. It's what? 2 comma 3, right? But what are the total number of elements? It's 4 into 3, that is 12, right? So can I say the index of this element in 1D array is 12 minus 1, right? Can I say this? The total number of elements are 12, so the index will be 11, right? So I am doing what? I am converting this 2D array into the 1D array. I am saying left is 0 index, the element at the left is 0 index, okay, and the right index will be 11, because the formula will be m into n minus 1, okay, the total number of elements minus 1, correct? So this part is clear, right? For everyone, we are converting this 2D array into the 1D array, and we are getting the index of the first element, that is the left, as 0 and right as 11, that is m into n, that is the total number of total elements minus 1. Got it? This part is clear. Now can we apply binary search on this part? Yes, we can, but while let's say we will get the mid element also, it's 11 divided by 2, we will get 5, right? So what is 5? this is 1 2 3 4 5. This is the mid element, right? This is the mid element. Now we will compare with the target. What was the target? It's 3, right? It's smaller. Now we need to update the what? The right and the left. But before that, how we will compare it? We can't compare like nums of mid, that is 5, right? Num of 5. This is not valid because this is a 2D array. So we need to convert this mid in terms of row and column, right? We got mid as 5. We are just assuming like this is the 1D array and these will be the indexes. We will get the mid element from that. Now we need to convert this mid in terms of row and column, right? How can we do this? We have mid as 5. How can we convert to rows and column? I'm saying it will be mid divided by what? N. What is N? N is the number of columns. And this is mid modulus N. Okay. So what I'm saying, let's write it again. 1 3 5 7. This is first row. Then 10 11 16 20. This is second row. 25 30 34 60. And this was the mid element. We have mid as 5, right? The left 0, right 11. Now we need to convert it into row and column. We were using formula mid divided by n, mid modulus n. Now why we are dividing this by n? See, what is n? Number of columns, right? Or what we can say, number of elements in each row, right? This is first row, this is the first row, this is second row, this is third row, right? So we can get the row number by dividing by the number of elements, right? If it's 5, it will be here only, right? So 5 divided by 4, we will get 1. Got it? That means the first index. If we calculate the row for these, it will be the last element is 3. 3 divided by 4 will be 0. Got it? Because the number of elements in each row is 4 and we are dividing the number with that number. So we will get the, what we will get? We will get the basically the row number, right? See, let me again explain it again. 1 3 5 7, then 10 11 16 20 16 and 20. The last one was 25 30 34 and 60. These were the rows, right? And this was the middle element, right? Middle element. Now the number of elements in first row is 4. The number of elements in second row is from 1 to 4, from, or we can write the indices, that is 0 to 3, 0 to 3. Total 4 elements, right? And here it will be from 4 to 7. The next 8 elements, next 4, that is total 8, right? Here it will be from 8 to 11, the next 4 elements, right? So 5, where 5 will come? We can simply divide it, right? First 4 will come here, the next 4 will come here, right? So the fifth element will be here somewhat, right? Got it now? The next 4 will come in the next row. So we are getting the row number by dividing it by number of elements in one row. This is simple math formula, right? So we will get the row number by just dividing the element, that is the number of element, that is fifth by the total number of elements in one row. Okay, so it will come 1, that is the index of the row. Okay, now what about column? It's mid modulus n. See, the total number of columns are, this is first column, this is second, this is third, this is 4. Total are 4, right? So now we need to get which is the column for this. We will divide it, right? So the mid was 5 divided by 4, it's 1. We got 1. So we got 1. Okay, let's say this is 4. Okay, 4 divided by 4, it's 0 only, right? The remainder will be 0. That means this is the first column, it's coming under the first column. Now if it's 6 divided by 4, it's what? 2. That means it's coming in the second position, right? Correct. We are having total 4 we can say columns, and we are dividing the number by the total number of columns so that we can get in which column it's lying. Got it? 1, yes, 1 is the index for this, right? This is 0, this is 1, this is 2, this is 3. These are the index for the column. Again, this is the simple math formula. So this part is clear. We need to convert it into the rows and column, and we will be using these formula. For row it will be mid divided by n, and for the column it will be mid modulus n, right? Now we got the mid, this was the mid, right? Mid element, row was 1 and column is again 1, right? We got the row and we got the column for the mid element. Now we will compare it with target, right? With the target, if it's equal to what? Let's say this is nums of row and column. If it's equal, then we can simply return row and column. Okay, row and column. Otherwise we need to check what is the next window, right? It's left or right. So we will check if target is smaller than what? Smaller than nums of C and R and C, that is the mid element. Okay, that means the element lies on the left side. We need to update the window, that is the right will be what? Or right will be mid minus 1, right? Mid minus 1. Otherwise it will lie on the right side. We will update the left pointer, it will be mid plus 1. Okay, that means after this element, this window, right? So again we will calculate the mid from this window. Let me write this. We are having 1, 3, 5, 7, then 10, 11, 16, 20, then 23, 30, 34 and 60. This was the 2D array and we are assuming it as 1D array. We are having left here and right here and middle here. Now we are updating the new window. Now it's lying here, the target is here, so we need to update the window, that is the right element, right index. We will update mid minus 1. So now here will be the right. Again we will calculate the mid element, right, by dividing this. Okay, we will get the new mid. Again we will check these conditions and so on, right, within the while loop. Okay, then let's code it. Okay, so initially what we will have the size. Okay, so matrix dot length, this is the row size, and we will also calculate the n, that is the matrix of 0 dot length, that is the column size. Okay, now we will check if what is the base condition. Let's say we are having row or column as 0, then we can simply say it's not possible, our elements are not there, right? So we will check the condition if m equal to 0, or then we can return false, right? Otherwise what we need to do, just a second, we will be having two things, right? We need to calculate the mid element and what else, the start and the end, right? The start will be at 0, the end will be, what is the end? It's m into n, right? M into n minus 1, correct? The last element. Then we will be having the while loop till start is smaller than equal to end, right? Now we will be calculating the mid element, that will be equal to the start plus end divided by 2. Got it? Now after that we will calculate the row and the column for the mid element, right? So this is the important thing. We will be having the element, right, matrix of, what is the row? Row will be mid divided by n. This is mid, this is also mid. Got it? This is the row, and what is the column? It's modulus of n, right? Using these formula we will get the row and the column for the mid element. Got it? After that we will check the condition if target is equal to element, that means this is the correct element, and we will return true, right? Otherwise we will update the window, correct? We will check target if it's smaller than the element, the mid element, right? That means this is the left window. We will update the right. Right will be equal to mid minus 1. Got it? In the else condition we will update the left part. Left equal to mid plus 1. At the end we can return false. Okay, let's run this. What is the issue? RAGST. Okay, it's not. It's end and start. Accepted. Let's submit this. We are checking the conditions here, and we are getting the row and column for mid, right? Okay, it's clear. Then let's move to the next question. Okay, so this is a tricky one. This is basically a modification of binary search. Okay, so in this we need to search in a rotated sorted array. Okay, so basically we are given one integer array sorted in ascending order with distinct values. Prior to being passed to your function, the nums is possibly rotated to an unknown pivot index k, okay, such that the resultant array such that the resulting array is nums k and nums k plus 1 till n minus 1. Okay, so let's see the example. So this is the array given, right? So basically here you can see some part is basically there are two parts, right? This is sorted and this is sorted. Like previously it will be 1 2 4 5 6 7, but before passing to the function they made some rotations, and after rotations it's like this 4 5 6 7 and 0 1 2. Okay, so this part came in the beginning. Okay, so now we are having some kind of unsorted array, right? But within that we are having two arrays which are sorted. This is sorted and this is sorted, right? Correct. Now target is 0. We need to find the index for that. How can we do this? Can we apply binary search here? One thing is we can simply traverse the array and check if 0 is present or not. We can return this, right? But that will take n time complexity. We need to return the algorithm in log n time complexity. How can you apply binary search here? This is the question. We are having two parts. This is also sorted, this is also sorted, but we don't know like from where it's ending and it's starting, right? It can be like this 4 5 or 6, then 0 1 2 3 5, not 5, only 3. This can be also there. So here this is one sorted array and this is one sorted array, right? So we don't know basically where is the different array different array starting, right? So what we can do here? Anyone? We will apply the binary search, but within the conditions we will also check, like if the, let's say, what is the middle element here? It's 7, right? So we will check if the left part is sorted or the right part is sorted, right? Either one of them is sorted, right? So this is clear, this is obvious that either one part will be sorted. So here we can see this part is sorted, right? And this part is not sorted, right? From mid to this point. How can we check the part, the array is sorted or not? We will simply check. See, 4 5 6 7 0 1 2, right? This is the array and this was the middle element. We need to check if left part is sorted or the right part is sorted. What we will do, this is the mid element, this is the left, this is the right. We will check if left is smaller than the mid. Left is smaller than mid. That means left part is sorted. Right? Because it's in the ascending order, right? So we can say it's sorted. We will also check for the right part. What is the mid? It's 7, right? Mid is smaller than right. Is this the condition? No. 7 is not smaller than 2. So right part is not sorted. Okay. So if we got the thing like left part is sorted within this, now we will be checking if our target is smaller than mid and greater than this left. That means this is the window, right? We will check for the target. Target should be greater than the left, right? And target should be smaller than mid, right? If this is the case, then this is our window. Then we will update the right. Right will be mid minus 1. Okay, got it. So first we need to know like which part is sorted. Within that part we will check these conditions. Okay, for the right also, let's say this was the example. Here mid element is this one, right? 0, right? Now here, what is the sorted part? It's right, correct? This is the sorted part. Now within this, we will be checking if target is greater than mid and smaller than right. That means it will be under this window, otherwise this window, right? Again, if this is in this window, again we will check the mid and calculate the left and the right, again calculate the mid element, right? So there are two things basically. We need to check which part is sorted. Within sorted only we can apply the binary search, right? So within sorted, the second step will be update the window, right? So first part is to get the sorted part. So we will get that either left will be sorted or right, and within that we will be checking the target, the conditions for the target, and update the window accordingly, and at the end we will get the target. Got it, everyone? See, what is the thing for binary search? First thing should be array should be sorted, right? Should be sorted. So within this, we know that either left will be sorted or right will be sorted, right? If we check this example, in this the left part was sorted, correct? And if you check this example, here right part was sorted. So first we will get the right or the left part, the sorted one, right? After that simple, we need to check the conditions. If this is within the window, that means we need to update the window, right? Either left or the right. For the left window, this is the logic. For the right window, this is the logic. Within this, we will be updating the left as mid plus 1, and there will be else condition also. Else condition, if this is not within the window, we will update the right as mid minus 1. Same for this condition. Okay, let's code it then. Okay, so first we will have the left pointer as 0, the right pointer as what? The last element, right? Nums dot length minus 1. Okay, then we will be having the while loop till when? Till left is smaller than or equal to right, and within that we will be having the mid pointer that will be equal to the left plus right divided by 2. Got it? After that, we will be checking the basically which window is sorted, right? Before that we need to check if the mid element is equal to the target. That means this is the resultant. We can return the index. Okay, if nums of mid is equal to target, that means this is the required answer. We can return the index that is mid, right? If this is not the case, then we need to identify the window, right? For the window, we will check nums of mid if this is greater than or equal to nums of left. That means this is the sorted window, the left side one. Okay, checking if left side is sorted. Okay, if it's sorted, we can apply the binary search. So now we need to check target will come under the left window or the right. Okay, if nums of left, okay, is smaller than equal to target, what is the second condition? Second condition was and the target should be less than or equal to nums of mid, right? If target is between left and mid, that means this is the right window, and we will update the right as mid minus 1. Got it? Otherwise, in else condition, that means we need to update the left as mid plus 1. Else, this was for the so this is for checking if right side is sorted. Okay, now within this we need to check these conditions. If nums of right, it should be mid, it should be less than or equal to the target, and the second condition is target should be less than or equal to nums of right. Got it? If this is the case, we will update the left as mid plus 1. That means this is the right window, and else we will update right as mid minus 1. At the end, we can return minus 1. Let's run this. Accepted. Let's submit this. It's accepted. So the question is capacity to ship packages within D days. Okay, this is the important question asked in companies like Google or Amazon. Okay, so what is the question? So basically, a belt has packages that must be shipped from one port to another within days. Okay, so days is given to us, that is 5, and the ith package on the belt has a weight of I. Each day we can load the ship with the packages on the belt in the order given by the weights. Okay, we may not load more weight than the maximum weight capacity of the ship. Okay, return the least weight capacity. Okay, so we need to return the least weight of the ship that will result in all the packages on the belt being shipped. Okay, so let's see the example. So we are given the weights of the packages, that is 1, 2, 3, 4, 5, 6, 7, 8, 9 and 10. Okay, and the days is 5. Okay, within 5 days we need to ship all the packages, right? And we need to return the minimum weight capacity of the ship such that it can ship all the packages within 5 days, right? So it can be like within 1 day it can ship 10, right? So first day it can ship 10 weights, total 10 weights, so it will be 3, 6 and 4, 10, right? So first day these packages, the second only this one, right? Because 5 plus 6 will be 11, so it should be under 10, right? So second day this, third this, then fourth, then fifth, then sixth, then seventh, right? Correct. So if the minimum weight is 10, then the number of days taking is 7, right? Total was 7, but we are having 5 days only, so we need to increase the capacity. Okay, now I'm asking you one thing: what can be the minimum minimum weight capacity of the ship? What can be the minimum weight capacity? Anyone? See, if we are trying to solve using binary search, we should have the minimum and the maximum capacity, right? What we are trying to get? We are trying to get the minimum weight, right? So we must be applying binary search on the weight, right? On the weight, what we are trying to find. So there should be a minimum and the maximum weight. Within that, we can apply the binary search and get the value, the minimum value, right? What is the minimum value for this weight capacity? Minimum weight capacity, like I said, we have the minimum and the maximum. Like in the earlier question, we are having the left and the right, correct? And we are calculating the mid, right? So this thing we need to apply on the weights. Got it? We need to find the weight. So we will apply this binary search on the weights. We will be having initially, we will be having the minimum capacity and the maximum capacity, right? So what is the minimum capacity? So at one time it can ship 10 weight, right? Let's say we are shipping only one package, that is the weight of that package is 10. So minimum capacity should be 10, right? So that it can ship all the packages. Got it? And what is the maximum? Okay, it's the sum of all the packages, right? So it will be sum of all the packages. It's 1 plus 2, 3, 6, 10, 15, 21, 28, then plus 8, 36, then 9, 45, 55, right? So it's 55. Now we got the minimum as 10 and maximum as 55, right? So our answer, that is the minimum weight capacity of the ship, should be within this, right? Within 10 and 55. Got it? Now we will calculate the mid element for this, right? So it will be 55 plus 10 divided by 2, 65 divided by 2. What is the remainder? 3, 30 and 2. Not 2. Yes, 2. It's 32, right? So 32. Now we will check if it can ship all the packages with this weight capacity, right? So this is the another thing, can ship all the packages with mid capacity, mid as minimum capacity of the ship within 5 days, right? 5 is given. Got it? This 5 is given. So now we need to check this. How can we check this? Anyone? If it can ship all the packages within the mid capacity, right, then we can say it's possible. So we can say this is the minimum capacity if it's equal to, right, if it's true, right? So what we are doing, how we are applying the binary search? See, we got the minimum capacity as 10, the maximum as 55, and we are calculating the mid. We got the mid, that is what, 32, right? Now in the binary search, what we are doing, we were checking if mid equal to target, we are returning the index or whatever, else in the else if we are checking if mid is larger than target, updating what, updating the right. Got it? Right equal to mid minus 1, else left equal to mid plus 1. Here how can we check, how can we apply these conditions? See, we will check if can ship with mid minimum capacity, right? So if its mid is the minimum weight capacity which we are trying to find. Okay, capacity. So we will check if it can ship the mid within 5 days. If we will get true, then we can say we will check for the minimum value, right? So we can say it's possible for the mid weight. So we will try for the minimum. So we will say right will be, that is the right. In this case it's max, right? This element, it will be mid -1. We will check for the even lesser value if it can ship for that value also, right? At the end we need to find the minimum weight capacity, right? So we will check for the every least value. Got it? Else if it is not possible, then we will check for the higher value, right? If it's false, then we will check for the higher value. We will check for the right side window. Min will be mid +1. Let's write the function. Okay, first write the logic for this can ship function. So how we will check this? See, we are having the values 1, 2, 3, 4, 5, 6, 7, 8, 9 and 10, right? These are the values. So now we need to check if we can ship these parcels within 5 days and with mid capacity, right? So in 1 day it can load up to mid weight, right? So how can we check? So we will be having one variable, let's say day count. It will be 1 initially. Then we will be having one variable, that is current load. Okay, it will be 0 initially. Then what we will do, we will be traversing through this array. Okay, these are the weights for each parcel, right? So let's say int w weight. Okay, now within this we will be calculating the sum. Okay, so it will be we will be calculating current load plus w, right? So we will be adding this w and we will check the condition. If at any point it's greater than this mid, that means this is above the capacity, we can't load this. Okay, so we will exclude that. Okay, so we will check if condition, if current load plus w is what, as greater than the mid, the capacity, basically let's write it capacity. Okay, the capacity, that means we can't load this. Okay, so at this point what we will do, we will increase the day count. That means the remaining package will come in the next day, right? So we will do day count plus. Okay, and we will initialize this as 0. Okay, for the new day it will be 0 only, right? And if this is not the case, means the regular one, we can load it, right? So we can update in the current load plus equal to w. And what else we need to do, we will check the last condition. If day count is greater than what, the number of days, that is the 5. If this is the case, then we can say it's not possible, we can return false. Okay, otherwise return true. Got it? What we are doing here, everyone? Say, we are having the weights, right? So we are loading the weights and we are checking if at any point the new weight, while we are adding the new weight and it's greater than the capacity of the ship, that means we can't load this, we can't load this. This can be loaded in the next day, right? So we will incrementing the day count and we are initializing this as 0, right? That means the current load for the new day will be 0, right? And at the end we are checking if day count, the total day count is greater than the days, the number of days, that is 5. If this is the case, we will return false, otherwise true. Got it? Okay, so let's code it. Okay, so we are having the low, right, which will be what? The maximum of all the weights, right? So let's say, let's make the function get max. Okay, get max and passing weights. Let's make this, or we can also have it here also. So it will be having public int get max. We are having the array, right, the weights. Within this we will be having one max element. Initially it will be 0. After that we will be applying for loop for each loop. Let's say w with weights, and we will be having the max value from max and the weights, right, the w. Got it? At the end we will return max. Okay, so for the high value we will be having the sum of all the elements. So let's write the function for that also. Public int get sum int w weights, right, and within this we will be having the sum. Initially it will be 0 and for loop will be there, w weights sum plus equal to w, right? At the end return sum. So get sum weights. Okay, so we got the lowest and the highest value. Now we need to have the while loop, right, till low less than high, and within this we will be calculating the mid element, right? Mid will be what? Low plus, we can also use low plus high divided by 2, but sometimes it overflows, right? So we will be using high minus low divided by 2. It's the same thing, you can calculate it, right? After that we will be checking if it can ship the all the packages within the 5 days, the given days, and the minimum capacity as mid, right? So we will check this. So we will be passing weights, the days, and the mid, right, the minimum capacity, right? If this is true, we can say we will update the window. We will check for the even lower value, right? So high will be now mid, right? Otherwise in else condition will be low will be mid plus 1, right? Let's write the code for this can ship. So public int can ship, it's not int, it's boolean. We will be having one array, right, the weights array. Second thing was days, and the third thing was the capacity, right. Now what we are doing here, first we were having the days, the day count, right, the day count initially 1. After that the capacity, the current load, okay, current load, it will be 0. After that we will be having for each loop starting with for each loop for weights. Within this, now we were checking one condition, right, so let's do one thing, current load plus equal to w, right, and before this if current load plus w is greater than what, the days, not the days, the capacity, that means we can't handle this in the current day, right, so we need to update the day count. Day count will be plus plus, current load will be what, again 0, right, for the new day. After that what we are doing, now we need to check if day count at any point, if day count is less is greater than days, that means this is not possible, right, we need to return false, otherwise return true. See, at some point, if we take this example 322,414, three two two 414, right, low will be 4 here, high will be what, the sum of all 5, 6, 12 and 4, that is 16, correct, 8 9 12 16, okay, 16. Now see, 414, now the middle element will be what, 16 plus 4 divided by 2, that will be 10, right, so we will check for the 10 if it's correct or not, right, so it will be possible. If you see this logic, so basically 2 plus 3 5, 5 then 2, 5 then 2 7, 7 1 day, then this 5 1 day, 4 1 day, okay, so total 3 days. What is the total number of days given? It's 3 only, right, so it satisfied the condition, so we will reduce it, or not. High equal to mid, right, so high will be 10 now, got it, and low will be 4 only. Again we will check for the middle, that is 7, right, for 7 is it possible or not, we will get this first, this second, this third, right, so 7 in the first day, 5 in the next day, 1 in the this 4 in the last day, right, so day was 3, so this is also satisfied. Again we will move this high into the high is equal to mid, that is 7, not 6. Why not 6? Because if we do 6, then it will be different for mid, right, So one mid will be missing. So for high as 7 and low as 4, we will get mid as 5. Got it? It's 5 only, right? 11 plus 11 divided by 2, it's 5. So for the 5, it will check. It is not possible, right? So 5, this is 5 first day. Now this is 6, it's not possible. So only this can ship, right? The second day, the third day, still the one package will be there, right? So we need to update the window. We will do what? We will do low equal to mid plus 1, right? So at this point, low will be 6, right? So we will return that. Got it? For 5, it's not possible, so we will do mid plus 1. We already checked all the elements, right? Above mid and basically the interval. We have checked the 16. We have checked the elements between 4 and 10, between 4 and 7. We got this 5. 5 is not possible, so next element will be possible, that is 6. I suggest you to solve similar questions, then you will get why we are doing high equal to mid and why we are returning this low. Let me share. So these are the questions. Try with this 12th ones. This is the similar one. Okay, this is the similar one. Try it by yourself once.